All right, Dr. Fraser here. We're going to just run through a basic stoichiometry problem here. And this is one that's found in your textbook. It's on page 278, and this is number 64. Okay, so the question in the textbook actually gives you the formula, and it says that 4 HCl's, hydrochloric acids, react with one oxygen molecule to produce two water molecules, which is in a liquid form, and two chlorine gas molecules. Okay, so let's figure this out. So to do this, it says that we have been given 63.1 grams of hydrochloric acid. That's going to react with 17.2 grams of oxygen. Okay, and then it tells us also that 49.3 grams of 49.3 grams of chlorine gas are collected. Okay, so that's what you can actually get out of this in the experiment. Okay, so let's run through this. So first it says that we need to determine what the limiting reagent is. To do that, we're going to have to convert our gram amounts of each reagent into moles. So let's just start with the hydrochloric acid. So we've got 63.1 grams of HCl. Alright, so to convert that to moles, we need to multiply that by a conversion factor that will give us moles. So I put that in the numerator, and we're going to divide that by the molar mass of hydrochloric acid, and that molar mass is 36.458, and that's just by multiplying the atomic mass of hydrogen and the atomic mass of chlorine. Okay, so then that would give us the number of moles of reagent, of the HCl reagent. Now, the other thing we're going to have to do is, what we're trying to figure out how much of the chlorine gas product can that make. Since the reason we pick chlorine is because it's already mentioned in the problem, and if we look down here for part B of the problem, we're looking for the theoretical yield of hydrochloric acid. So that's the one we're going to try to figure out for the limiting reagent too. Alright, so now we need to multiply, to figure out how much of that product we're going to get, we need to multiply this number of moles of HCl by the conversion factor that will get us from the reagents over to the products. So we're going to put the coefficient of the product, that's the 2 Cl2s, we're going to put that in the numerator, and we're going to put the coefficient of the reactant in the denominator. So that's going to be 4 HCl's, and that's moles of those things. Alright, so then we'll run the numbers on that, and so for the hydrochloric acid, for the 63.1 grams of hydrochloric acid, this will tell us that we can make 0.865 moles of Cl2. Alright, so now we're going to do the same thing, only we're going to use the 17.2 grams of oxygen. So we're going to try the other one to see if it's limiting. Alright, and we're going to multiply that by the same sort of conversion factor, moles over grams, so we can get to moles. Only here in the denominator we're going to put the molar mass of oxygen, which is going to be 32 grams per mole, and that's just the molar mass of the O2. So 16 plus 16 is O2. 16 for each oxygen atom in the oxygen molecule. Alright, so now then that means we got to do the same thing, only we're going to use not this same conversion factor, but we want to do a custom conversion factor for HCl. So the product again is going to be 2 Cl's, but in the case of oxygen, it's only going to take one oxygen. I should get rid of this again. I don't know why that keeps popping up, but it's only going to take one O2. I've lost my cursor. Where is my cursor? Alright. It's only going to take, there it is. it's only going to take one O2. So let me see if I can get back up here to this, get rid of that so you can see the equation. All right, so you can see here that there's only one O2 there. Okay, so if I run the numbers on that, then I'm going to get 1.075 moles of O2. Now that's kind of weird because it's saying that I'm sorry, not moles of O2, but moles of chlorine, the product. That's what I'm after there. Let me erase that. It should be moles of chlorine. Now what's weird about that is, and that's moles of chlorine, what's weird about that is we started off with only 17.2 grams of O2, but because you only have one molecule of O2 reacting, you can actually make more chlorine with that 17.2 grams of O2 than you can 63.1 grams of hydrochloric acid. So you get only 0.865 moles of chlorine. So that means that the hydrochloric acid here is the limiting reagent. So the answer for that would be the hydrochloric acid, because it will yield the lesser amount of the chlorine gas product. Okay, so now we need to figure out the theoretical yield. And the theoretical yield is going to be just how much do these actual equations tell us that we're getting when we run this reaction. So we're going to use the limiting reagent, and that's going to be the 63.1 grams, but we're going to start off with just what that yield is in moles, and that's in the product above. That's right here. So we're going to take that number, 0.865, and we're just going to multiply that by the molar mass of chlorine gas. So that's moles. All right, and we're going to multiply it by the molar mass of chlorine gas, and the molar mass of chlorine gas, Cl2, is 70.9 grams per mole of Cl2. So that means that moles are going to cancel out. Sorry, pause there for a second. Moles are going to cancel out, and we will get 61.36 grams of Cl2 from that. Okay, so that's our theoretical yield. And that's the answer to part B. And that leaves us with the question for part C, which is actually pretty easy. And that is, where'd that go? Well, anyway, that is what is the last part is what is the percent yield, and let me get back up here and get my pen. The percent yield. So the percent yield is the third part in that question. I don't know how that got left off of there, but basically we're going to take the observed yield, which was up here in the question, at 49.3 grams of Cl2. So I'm going to take 49.3 grams of Cl2, and I'm going to put the theoretical yield in the denominator. That's 61.36 grams, and that will give me 80.4 for my percent yield, 84.4. So the answer would have been 0.804, and I just converted that to a percentage to get 80.4 on the percent yield. So that's basically how you do a standard stoichiometry problem.